Okay, excellent. So remember what we said. It's a very good question. This function is not defined at 2. That's very clear. So we want the function to look like this, because there is no equal symbol anywhere. So we want the limit from the left and the limit from the right to exist, to be the same and exist, of course. So I have to find the limit as x approaches 2 from the left. Which branch will I use? I can only use one.
Negative x plus 8.
So x approaches 2 from the left.
The first one.
Good. 1/2 x plus c. Is that clear? Can anyone give us this answer?
I'm confused. Why are you trying to solve for the limit from the left? Because the question was just asking to find the limit of.
Very good. By definition, the limit of f of x as x approaches a from either side exists if and only if limit as x approaches a from the left equals the limit as x approaches a from the right. So I'm going to dig up what we wrote. Okay. So we said the limit exists at 3 because the limit from the left and the limit from the right are both exist and they are the same number. They may or may not be equal to the limit to the function value. We don't care. But the limit at 3 from either side exists only if the limit from the right and the limit from the left both exist and are the same number. That's the definition. The limit of f of x as x approaches a from either side requires the limit from the left and the limit from the right both exist and equal the same number. The limit from the right and the limit from the left both exist and they equal the same number. But here, the limit from the left and the limit from the right, they both exist, but they are not equal to the same number. So therefore, this limit does not exist. Is this okay? Is that a yes?
You're saying that the limit of as x approaches 3 exists only if the limit from the left and the limit from the right both equal the same number. Is that what you're saying?
Exist, both exist, and both equal the same number. Otherwise, the limit from either side will not exist. And this is the example in which the limit from the left and the limit from the right, they both exist, but they're not the same number.
Okay.
So then the limit from either side is DNE.
But isn't the question determine the value of c?
We haven't gotten there yet.
Oh, okay.
There was a question I had to answer, right? I couldn't just say.
Oh, okay. I got lost.
No. So can anyone give us this limit, please? This should be a blank. What is this?
I want to say 2.
You cannot say 2.
That minus x plus a?
We are working on this limit.
1 plus 1.
1 plus c, indeed. Great job. When I apply the limit operator to an expression, that's what I'm doing. When x approaches 2, 2 times 1/2 is 1. 1 plus c is 1 plus c. I apply the limit operator. So now let's determine the limit as x approaches 2 from the right. Which branch? Again, this should be just a blink.
Negative x plus.
Good. Perfect. Can anyone give us the limit here? We know how to find the limit of a polynomial. We discussed that. So this is a polynomial. So how do I get this?
6.
Good. For this limit to exist, what has to happen?
C gonna be 5.
1 plus c must equal 6. Exactly 5. So then f of x is 1/2 x plus 5 for x less than 2, and negative x plus 8 for x greater than 2, guarantees the limit from either side of 2 to exist. Very good. Is this clear for everyone?
Oh, I did it a little differently.
There is no other way. In this particular case, this is the only way. You have to determine the limit. You have to write 1 plus c. You have determined the limit. You have to write c, and you have to state why this is the case. There is no other way. You have to say the limit from the left has to equal, they both have to exist, and they have to be equal for the limit from either side to exist. And the limit from either side is indeed 6. So the limit from f of x as x approaches 2 from either side is obviously 6. How are we doing with this? Is it okay?
So basically, to solve these type of equations, you plug in for one of the equations what x approaches if you can, if they're both equal, and then
I have to
once you
determine
get-
the limit. I'm not plugging it in. It happens that it works that way. I have to determine the limit from the right, the limit from the left, and the limit from the right, and set them equal to each other for the limit to exist. There is no other way.
We can do 1 over x plus c is equal to 2 minus x plus a. I always try to do like that. I don't know.
No, there is no need for that. The limit requires, for this to exist, you have to show limit from left and right. It makes no other sense. The limit from either side exists only if the two limits exist and they are the same.
That's
So-
why my attention was if 2 limits exist equal number.
But you have to write the limit. If you set this equal to this, that's not what we're trying to do. We are not interested in the function value at that point. We are interested in, first of all, you cannot even plug in 2 because 2 is nowhere to be found. We are plugging in 2 because it's inside a limit. There is no way you can plug in 2 here.
What do you mean it's inside the limit?
I am allowed to plug in 2 here because it's a limit operator in front of it. If you're asking me to plug in 2 here, I'll say I can't. I'm sorry. 2 is nowhere here. But inside the limit of this, yes, you will be plugging in x equals 2. But here you cannot plug in 2. It's not allowed.
Can you do question 23?
Yes, but it's the same thing. Sure, of course, the answer is definitely yes. So all you have to do is just put the limit in front of this and determine it, the limit in front of this and determine it, and then set them equal to each other. You cannot plug in 2 in the function value. You cannot do that. You cannot plug in 2 here. But when you determine the limit, it's a different story. You are, say that again?
But by determining the limit, wouldn't you be plugging it in?
But inside the limit, you are allowed to. In the function, you are not. So,
Okay, so once you
when we have,
use the limit to plug it in, then you use that equation that you get.
that's a different story because you basically expressed the fact that the limit from the left and the limit from the right have to equal each other. you're not allowed to find f of 2. It doesn't exist. You can't plug it in. But when I'm talking about the limit, we talked about the limit, and we said that the function doesn't have to be defined there. And the function is not defined there. So we had situation in which the function, without this point, is not even defined there. Nobody allows me to plug in 5. I'm not allowed to. But when I determine the limit, I'm determining the tendency, not the function value at that point. So the limit concept has nothing to do with the function value, which, by the way, in this function, it does not exist. So when I determine limit as x approaches 2 from the left, I will use x squared minus 7. And there is a theorem that we discussed last time. Let me stop sharing. There is a limit that we discussed last time. Can I determine the limit of a polynomial? Yes. 4 minus 7 is negative 3. Can I determine the limit as x approaches 2 from the right, which is limit as x approaches 2 from the right from negative x squared plus c? Yes, I'm allowed to do this. So this is negative 4 plus c. So negative 3 must equal negative 4 plus c for the limit from either side to exist. So then c is 1. And the limit is negative 3. But plugging 2 in either one is incorrect and impossible. Inside a limit, yes, this is, I'm plugging in 2 inside a limit. In here, inside this limit, I can plug in 2. In here, I cannot plug in 2. And I don't even care. What I care is to determine that the limit, to find the limit from the left and the limit from the right, and set them equal to each other. That's what I care about. I don't care about the function value. The limit does not have anything to do with the function value. It only expresses tendency. From the left, the tendency is negative 3. From the right, the tendency is negative 4 plus c. If these two are not equal to each other, then this limit does not exist. I set them equal to each other to find c. And now from left and right, both limits are negative 3. So the limit from either side is negative 3. Do not attempt to plug in 2 here. That is not correct. You can't. Which one do you plug in? None of the above. You can't. Good. It was a very good discussion and very good question. Can we move on? Do we have anything else? Yes, Tess, you had something else? Or we move on, you said.
No, I'm sorry. I'm good.
Okay, so let's continue.
But my question is, even if it is x minus x less than 2, x less than or greater than 2, we know which is left, which is right. We cannot plug into there.
Not in the function, you cannot. Not in the function.
No,
Inside the limit, yes. Inside the limit, yes. We discussed this last time, yes. The limit of a polynomial is f of that function. But it doesn't mean that the function exists there. We never discussed that the function has to exist. Quite the contrary, we looked at examples in which the function didn't even exist there.
Thank you.
Okay, very good. Other questions? Okay, so then back to 1.2, and trying to look at some other limits. We looked at, let's look at a radical limit. We didn't get the chance to look at 27. So limit of 9 minus x divided by the square root of x minus 3 when x approaches 9. Now, the first limit that we looked at was, maybe I should keep this here and not throw them again. Okay, so the first limit was the limit of a polynomial. The second limit was the limit of a rational function. Now this is a limit of a totally different function, It's a function that is a combination of a rational function with radical. What do we have to do first? Every time we're asked to find the limit, any limit from any function, what is the first step?
Denominator shouldn't be 0.
So the first step is always plug it in. This is the first step always. I don't know what this is. So, and you can say again, and I emphasize again, x does not equal 9. Why are you making me plug in 9? I have to, because I don't know what this is. Maybe the answer is 5. And if the answer is 5, I'm done. I'm moving on to the next problem. Maybe the answer is 5 divided by 0, and then I'm in trouble, because I have to define the infinity, negative infinity, DNE. But what if the answer is 0 over 0? Then it's a different story. So these are 3 possibilities. All of them are feasible, possible. So if I don't know which situation I have, I cannot move on. So I have to plug in x equals 9, although x approaches 9 means x does not equal 9. So what do we get? When we plug it in, we get what?
0.
No, we don't get 0.
0 over 0.
Yes, we do get 0 over 0 indeed. Okay, so then I know that is not this, nice and easy, is not the ugly one, which does not exist, or it's infinity or negative infinity, is this one that has hope. Okay, what do we do next?